Hello everyone, we are continuing on with our lesson 16.1, our dynamic climate. And today we're going to start off with the oceans and the climate. Like winds, ocean currents transport heat over long distances. In addition, ocean water absorbs carbon dioxide, and this has a cooling effect. So what happens is we have ocean circulation. This is when ocean water exchanges huge amounts of heat with the atmosphere, and the ocean currents move heat energy from place to place. A worldwide system of ocean currents is caused by a combination of unequal heating of water and unequal salinity. And salinity means salt concentration. So the higher the salinity, the more salt that's in the water. We have thermohaline circulation. That's when cool water generally has a greater density than warm water. Saltier water is denser than water with lower salinity. Therefore, warmer, less salty water moves along the surface of the ocean, and colder, saltier water moves deep beneath the ocean's surface. This pattern is called thermohaline circulation. As part of this pattern, cooler, saltier water at the poles sinks, and warmer, less salty water from the equator moves to take the place of the cooler water. In the Gulf Stream in the Atlantic Ocean, warm surface water flows northward from the equator. The warm water keeps Europe warmer than it would be otherwise. El Niño and La Niña. The interactions between ocean and atmosphere, called El Niño and La Niña, affect climate. El Niño is a change in air pressure, wind pattern, ocean temperature, and ocean circulation in the Pacific Ocean. Normally, prevailing winds blow from east to west along the equator. The winds help move warm surface waters westward. During El Niño, however, equatorial winds weaken, and the surface water in the eastern Pacific Ocean becomes warmer than usual. In the next slide, we're going to see diagrams of this pattern. El Niño has a major effect on weather worldwide. For example, it causes rainstorms and floods in areas that are usually dry, such as Southern California. The pattern known as La Niña is the opposite of El Niño. During La Niña, temperatures in the eastern Pacific Ocean are colder than average. Like El Niño, La Niña disrupts weather patterns worldwide. A quick fact before we move on is, did you know the ocean absorbs a lot of carbon dioxide? Causing a global cooling effect, the ocean can hold 50 times more CO2 than is actually found in the atmosphere. Now we can see the images of El Niño. First, we have a figure A on the left side of the screen. This is normal conditions. Normally, wind pushes warm waters towards the western Pacific, as opposed to in B, El Niño conditions, where we see the winds weaken and the warmer water flows back across the Pacific towards South America. El Niño changes precipitations all over the world. So, yes, oceans can absorb carbon dioxide. Carbon dioxide moves back and forth between the atmosphere and ocean water. Oceans can hold 50 times more carbon dioxide than is found in the atmosphere. Since carbon dioxide is a greenhouse gas, the absorption of carbon dioxide by the ocean has a cooling effect on the atmosphere. However, the oceans absorb carbon dioxide more slowly than it is being added to the atmosphere. Therefore, carbon absorption by the oceans is slowing global warming, but it's not preventing it. Oops, sorry about that. Next, we're going to take a look at other factors that affect climate. Other factors besides the sun, atmosphere, and the oceans can also affect climate. 4 of these factors are topography, volcanoes, regional distribution of vegetation, and changes in Earth's path around the sun. Either before or after we talk about these in detail, you can take a look at the YouTube video, Understanding Natural Climate Cycles. So first we're going to talk about topography. A region's topography describes the surface characteristics of the area, including its elevation and features such as mountains, rivers, and lakes. The characteristics of a region's topography affect its climate. 2 of these are altitude and the presence of mountain ranges. First, altitude. Mount Cayambe in South America is located right on the equator. However, its peak is always covered with snow, as are the tops of many high mountains near the equator. In general, the greater the altitude, or elevation, the cooler the air temperature will be. That is why the kinds of plants at the bottom of the mountain are usually not the same varieties as those found higher up on the mountain. Mountain ranges. Well, as winds pass over mountains, the rising air cools and the clouds often form. Then precipitation may fall from those clouds. By the time the air has moved to the other side of the mountains, however, it has usually lost much of its moisture. In general, precipitation falls on the windward side of the mountain ranges, which is the side that the wind first passes over. The leeward side of the mountain range, or the downwind side, gets relatively little precipitation. Figure 5 shows us a snow-covered mountain, and even though this mountain is on the equator, we can clearly see that its peak is covered in snow. Next, volcanoes. An erupting volcano may expel huge amounts of gases and particles, as we see in Figure 6 to the left. Winds can carry these materials to areas that are long, and far away from the volcano. If the eruption is large enough, the gases and particles may block some sunlight from entering Earth's atmosphere. This blocking of sunlight may in turn cool the atmosphere. The cooling is temporary, however, because the volcanic material remain in the atmosphere for a limited amount of time. Figure 6 shows us a volcano erupting in New Guinea. And you can clearly see how the thick, dense ash, soot, and smoke released from the volcano could clearly block the sun radiation from penetrating to the Earth's surface. Regional vegetation. Plant life or vegetation can influence climate when it covers a large area. For example, the abundant vegetation of the Amazon rainforest promotes cloud formation and rainfall. In addition, plants affect the amount of carbon dioxide in the atmosphere because they use carbon dioxide in the process of photosynthesis. Huge forests take in an especially large amount of carbon dioxide. This intake decreases the amount of carbon dioxide in the atmosphere. However, when large sections of forest are cut down, the loss of trees means that the carbon dioxide they would have used remains in the atmosphere. Therefore, the destruction of forest in one area can actually increase the temperature of the atmosphere worldwide. In the figure on your screen, you can see landscapes showing different types of vegetation. We have A coastal dune shrub, B, a pioneer dune vegetation, C, tropical subdeciduous forest in young soil, D, tropical subdeciduous soil in old soil, E, tropical deciduous forest, and F, the tropical deciduous flood forest with wetlands. The last thing we're going to talk about as far as affecting climate is the changes in Earth's orbit. Evidence indicates that during Earth's history, climate has changed many times. For example, in the last 3 million years, Earth has gone through a series of ice ages. During these ice ages, huge glaciers covered large parts of the northern hemisphere. Many large animals that are now extinct, such as the woolly mammoth, survived in the frigid climate. One cause of these climate changes is the periodic variation in Earth's movement and position in space in relation to the sun. Minor changes in Earth's orbit and in the tilt of Earth's axis occurs in regular cycles. These cyclic changes affect the distribution of solar radiation over Earth. Earth's surface. This change in the distribution of sunlight can affect the climate. Climate changes caused by these variations may last for very long periods of time. Go ahead and stop here and answer your questions in your workbook, page 286 and 287, number 18 and number 22. We're at the end of chapter 16.1, so let's review some of the key concepts we covered on Monday and Tuesday. We learned that the heating of Earth's atmosphere by the sun is influenced by the greenhouse effect, latitude, and spotlight cycles. We also learned that wind distributes heat and moisture globally. Next, we learned that oceans affect climate by transporting heat and absorbing carbon dioxide. And lastly, we learned about that the global climate may be affected by factors such as topography, volcanic eruptions, regional vegetation, and changes in the Earth's orbit. This is the end of Tuesday's lecture. So make sure that you stop and you complete all of your classwork, homework, and watch all of the attached videos in LMS. And again, I have the answer keys posted on the PDF version of the PowerPoint, also posted on LMS. Bye, guys.